Hi everyone, my name's Jason Roberts and welcome to my course Testing .NET Code with XUnit.net Getting Started. I'm a freelance developer and author. It's always expensive, stressful and time-consuming to fix software bugs after they've been released to production. A good set of automated tests helps to verify that the application is working as expected and helps to prevent these bugs from making their way into production. In this course, you'll learn how to use the XUnit.net testing framework to create and run automated tests. Some of the major topics that we'll cover in this course include how to create a new XUnit.net test project, how to verify different types of results, how to customize and control how your tests get executed, how to group and execute subsets of tests using categories, and how to reduce the amount of test code you need to write by creating data-driven tests. By the end of this course, you'll know how to use XUnit.net to create your own automated tests to help you find bugs before they get to production. Before beginning the course, you should be familiar with basic C# programming. I hope you'll join me on this journey to learn how to create automated tests with the Testing.net Code with XUnit.net Getting Started course at Pluralsight. Hi everyone, I'm Jason Roberts from Pluralsight. Welcome to this course, Testing.net Code with XUnit.net Getting Started. .NET and .NET Core give us great programming ecosystems, and no programming platform is complete without a way to help ensure code is free from defects. No one likes to receive an emergency out-of-hours support call in the middle of the night because of a production outage, especially when the outage could have been avoided by finding the problem sooner during development with an automated test. The XUnit.net testing framework allows you to create automated tests for your .NET Framework or .NET Core code. This course is divided into a number of separate modules. In this first Getting Started module, we're going to learn some background on automated tests and see how we can create a new XUnit.net test project. We'll get to work creating our first test, and we'll see how we can execute this test at the command line and also in Visual Studio. In the next module, we're going to learn how to determine if a test is passing or failing by using the concept of asserts. So we're going to learn how we can assert on different values, such as numerics and strings, and also more advanced topics such as asserting on collections and object types. Following on from that, in the next module, we're going to learn more about controlling test execution. So for example, we'll learn how we can categorize tests and execute only tests in specific categories, and how we can configure test output messages. In the final module, we'll learn about data-driven tests. This is a technique that can help us to reduce duplicated test code. So for example, rather than having 5 tests all testing the same thing just with different test data, we can instead create one test and run that test 5 times with a set of test data. So let's take a look at what we'll be covering in this first module. We're going to start off with a brief overview of why we might want to write automated tests in the first place. We'll then get an overview of the different test types, and we'll have a brief discussion about testing behavior versus testing private methods. We'll learn about the 3 logical phases of an automated test, and then we'll start to introduce XUnit.net itself. We'll learn how to create a new XUnit.net test project, both at the command line and in Visual Studio, and we'll then go and start to create our first test. Finally, we'll learn how we can execute tests using the .NET command line interface or using Visual Studio's Test Explorer. So let's kick off this module by learning why we might want to write automated tests in the first place. So there's a number of benefits that automated tests can give us. First off, once they've been written, they're free to run as often as required. Other than any running costs such as electricity, we can run these tests over and over again without additional expense. We can execute automated tests at any time of the day or night, either on demand, such as when we finish a piece of work, or scheduled to run, for example, overnight at midnight. Automated tests can run very quickly, more quickly than, for example, trying to test manually, And essentially this speed of execution helps us find errors sooner, and generally the quicker we find errors, the less costly they are to fix. Automated tests are generally very reliable. If they've been written correctly, all other things being equal, tests should either pass or fail in a reliable manner. The automated test code that we write can sit in source control alongside the production code, so our tests shouldn't get out of sync with the actual production code they're testing. And automated tests can contribute to overall happiness in the development team. For example, if we spend less time fixing problems in production, we actually have more time to develop new and potentially more interesting features that can add value to the business and the end user. Also, with a good suite of automated tests that find errors sooner, hopefully we can avoid more production outages and also hopefully less out-of-hours callouts. We can split automated tests into a number of different categories. There's a range of terminology out there to describe the types of unit tests. In this course, we're going to describe tests as belonging to one of 4 categories. We'll have a look at these categories in just a moment, and what we're going to do is plot them on a graph. The y-axis of this graph represents the depth of testing. So this is how detailed the test can potentially get, so getting into all of the nitty-gritty details of the thing we're testing. On the x-axis here, we're going to plot test breadth. This represents how broad the test is, or how many different subsystems of the application we're developing the test can potentially cover. So let's start off here with unit tests. A unit test may test a single class, or perhaps a small unit of functionally cohesive classes, and unit tests offer us the best depth of testing. We can get right into the detailed behavior of the class and check it's all working as expected. Unit tests, however, don't have a broad reach. So a unit test wouldn't cover the whole system stack right from the user interface down to the database, for example. Next up, we have integration tests. These are potentially less in-depth than unit tests, but they cover a greater breadth of the system. For example, integration tests might test subsystems working together and potentially external resources such as databases or the file system. Next, we have subcutaneous tests. These type of tests operate just under the user interface of the application. This means that they can potentially cover a greater breadth of the system we're developing, but not as in-depth as unit tests, for example. Finally, we have functional user interface tests. These tests can cover the greatest breadth of the application, right from the user interface, for example, a user clicking a button, all the way down through the subsystems, even right down to the database level. Because we're automating the user interface, so typing text into text boxes and clicking buttons, for example, it's harder to get down into all of the nitty-gritty detail of each class. So functional UI tests here usually don't cover all of the nitty-gritty detail of all of the classes in the system. We can also think about these types of tests in a couple of different ways. First off is test execution speed. The tests that execute the most quickly and consequently give us the quickest feedback are usually unit tests. The slowest form of test here are the functional user interface tests, and that's because we're actually using the user interface, so we have to wait for the UI to refresh before we can move to the next phase of the test. Another aspect that we can consider is test brittleness. So that's how easy the test is to break or require refactoring when we change parts of the application. Usually, unit tests are the least brittle type of test because they're confined to a small unit of functionality. On the other hand, user interface tests can be more brittle. Not only do they execute a wide breadth of system functionality, because they also rely on the user interface elements being accessible. For example, if we change a button to be a text box, the test may fail because the test is expecting to find and click a button, whereas now the button doesn't exist. One thing to bear in mind when creating tests is to focus on testing the behavior of the class rather than the internal implementation, for example, the private methods. So for example, say we have this sleep method here, and this method belongs to a player character class that represents a player character in a role-playing video game. This sleep method allows the player character to regenerate some health, and it does this by calling the calculate health increase method. This method just increases the health by a random amount. Notice this calculate health increase method is private. This means the test code in the test project won't be able to call this method directly. Our tests, however, will focus on testing the public interface or the behavior of the class. This means our tests would call the public sleep method here, and after this method executes, our test code could look at the health property and check that the health has increased. There is some debate on whether we should test private methods or not, for example, making them public so our test code can access them. There's a number of drawbacks, however, to testing private methods. One, we're changing the visibility of the method just so we can test it, and this may break the concept of encapsulation in object-oriented programming, and also our tests now are testing the implementation details of the class rather than the class behavior. This means if we want to refactor how the class works internally, we may break a lot of tests and have to go and refactor those tests because our test code is tightly coupled to the implementation details. On the other hand, if we're only testing the public interface or the behavior, we could go and refactor this calculate health increase method. For example, we could go and change the name of this calculate health increase method, and it's not going to break any of our tests, because it's a private implementation detail that our tests don't need to know about. If you do decide, however, that you want to test private methods, rather than making them public, we can change the access modifier here to internal. In the production code project, in the assembly info file, we can add the internals visible to attribute. This attribute takes an assembly name, so this assembly name would be our test project, in this example GameEngine.tests, and now the test code in the test project can access the internal members of the production code.